In the beginning, the universe should have ended. That is not an exaggeration. It's the terrifying truth that has puzzled physicists for nearly a century. According to the laws of physics, when the Big Bang exploded everything into existence, it should have created equal amounts of matter and antimatter. But here's the problem. Matter and antimatter can't coexist. When they meet, they annihilate each other in a flash of pure energy, leaving nothing behind. If everything had happened the way our equations suggest, then every atom, every planet, every galaxy, and you should never have existed. So why didn't the universe vanish the moment it began? Why did matter win the ultimate cosmic battle? And what secret tipped the scales in our favor? The answer may lie in one of the most groundbreaking discoveries made by the Large Hadron Collider. Hidden beneath the border of France and Switzerland, the LHC is the world's most powerful particle accelerator, and it has been slamming particles together at near light speeds to uncover the deepest secrets of the universe. In recent years, the LHC began to observe tiny, elusive differences between matter and antimatter particles. Differences that can finally explain why the cosmos exists at all. This imbalance, called CP violation, might be the key to understanding how matter gained a microscopic edge in the early universe, an edge that allowed it to survive, flourish, and become everything we know. But before we dive deeper, let's break it down. Antimatter is not science fiction. It's real. For every type of particle that makes up matter, electrons, protons, neutrons, there's a mirror twin called an the same mass, but the opposite charge. When a particle and its antiparticle meet, they cancel each other out in a burst of energy. This is called annihilation. It's violent, absolute, and incredibly efficient. So, during the Big Bang, when both matter and antimatter were created in near equal amounts, they should have instantly wiped each other out. Yet here we are. So what went wrong? Right? That's the mystery the LHC has been chasing. By studying particles called beam and their antimatter counterparts, scientists noticed something strange. These particles don't behave exactly the same. They decay at slightly different rates. At first, the differences seemed minuscule. But in a universe governed by symmetry, even a tiny asymmetry can have massive consequences. Imagine flipping a coin 1 billion times and expecting it to land evenly between heads and tails, but instead, head shows up just a few times more. Over time, that small difference can snowball into dominance. In the same way, a subtle imbalance in particle behavior may have given matter a critical head start. That means the laws of physics may have built-in favoritism, a bias so faint we're only now learning to detect it. And the implications are staggering. If matter and antimatter were truly equal in every way, we would not exist. Every bit of matter in the early universe would have found its antimatter twin and vanished. But something gave matter just enough of an edge to survive. And not just survive, expand. Cool. And eventually form stars, galaxies, planets, and life, you, me, everything. And yet, there's a chilling side to this discovery. For every particle of matter left behind, millions were annihilated in the process. The early universe was a violent battlefield of annihilation, and only the tiniest fraction of matter survived. That small victory those leftover particles are would make up our entire visible universe today. Every atom in your body is part of that cosmic residue. We are the ashes of a war between symmetry and imbalance, and somehow, improbably, we won. But the story isn't over. Scientists believe that the key to unlocking this mystery even further lies in neutrinos, those ghostly, nearly massless particles that pass through your body by the trillions every second. Neutrinos have antimatter versions, too, and recent experiments suggest they might also exhibit CP violation. If that's confirmed, it could add another crucial piece to the puzzle. It's possible that neutrinos, with their strange, slippery nature, played a hidden role in tipping the balance toward matter during the first seconds after the Big Bang. The LHC and other advanced experiments are digging deeper, trying to replicate the conditions of the early universe in controlled environment. Each collision, each particle decay brings us closer to understanding how everything around us managed to survive a universe that was designed to destroy itself. This is not just a scientific question, it's an existential one. Why do we exist at all? Why wasn't everything canceled out before it had the chance to begin? The answer may be hiding in the smallest corners of physics, in fleeting particles and vanishing traces of asymmetry. It may be that the universe wasn't perfectly balanced at birth, and that tiny imperfection was the greatest gift ever given. It allowed reality to unfold. It allowed atoms to bond, stars to shine, life to evolve. It allowed us to wonder about the very fact of our existence. So next time you look up at the stars, remember, the universe could have been nothing. A silent void of energy and absence. But some strange, almost invisible twist of fate gave matter the edge. And that's why we're here telling this story. If you found this journey through antimatter and the fate of the cosmos as fascinating as we did, make sure to like the video and subscribe to Beyond Stars. The universe is filled with mysteries, and we're just getting started.